There is going to be an Atwood machine question on your test, and I'll tell you specifically which one it will be like. And it'll be worth a lot. I usually make it worth about 7 marks because you're going to see it is about a 6 or 7 step question. We've taken some good progress from the beginning of the year when I could barely give you a 1-step question, where now I'm saying, no, I can give you multi-step. So an Atwood machine is a pulley system as seen below. The mass M2 makes it easier for a person or a motor to lift M1. M2 is called a counterweight in the industry. Elevators, for example, almost always have a counterweight somewhere in the infrastructure that you're unaware of. Ooh, here's a thought puzzle. We're going to vote. Suppose identical masses are placed on both sides of the Atwood machine, and one mass is lifted up. That's irritating. When released, how does the system move? It's a good question. So here's my Atwood machine analog. We're going to raise one mass higher. If there's no friction in this pulley, and I let go of this higher mass, what will happen? And here's our options. A, nothing. The system remains at rest. B, the higher mass falls because, gravity. Or C, the higher mass goes higher. Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of the answer. So we're all going to vote this time, aren't we? We are. So you got the thought puzzle. We've got identical masses. We're going to raise one higher. When we let it go, what'll happen? Who says nothing? Nothing's going to happen. The answer is A. I got 1. Oh, I got 2. Is that a vote? 3. 3. Okay, I got 3. No, the higher mass is going to fall down. Gravity. I got 1. I got 2. I got 3. I got 3. Now, when you let it go, the higher mass is going to go higher. Duh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Anderson, did you vote? Okay. I'm not going to answer your question. Instead, we're going to figure it out. How? You know what this is a good job for? This is a good job for a free body diagram. I'm going to zoom into this one. We're going to label this one. What are the forces acting on the left-hand mass? Get the obvious one, everybody. Yeah. mg. Is there a rope? What do we call the force from a rope? Good. Is it sitting on a surface? Is there a normal force? No. Okay. That's the forces acting on mass 1. What are the forces acting on mass 2? Get the obvious one. I was going to call them M1 and M2, but does it say both masses are the same? Then I'm just going to use the letter M for both of them. What else? Tension. Now, most of you picked option C, which means, I guess, you're thinking that it's going to accelerate in that direction, yes? Which means, I guess, you're thinking that the winner is this. So let's try that. Let's write an equation. Let's make that the winner. And now, once again, we're going to walk along the rope. When you're doing many body problems, you write the forces for along the rope. So let's see if we can do that. Who's winning? I guess mg. So what we're going to say then is anything that ends up pointing down once it gets to the right-hand side is going to be winner plus. So this tension right here is definitely going to be pointing up, loser minus. What about this tension? Now, you might be tempted to say, well, it's pointing up like this tension, so it's a loser. But, Dina, if you follow it, I think when it gets to that side, it ends up pointing which way? Down, which we've called winner plus on that side. So that. And then this mg right here, Annie, you might be tempted to say it's pointing down, so it's also a winner. But again, if you follow it, I think when it gets over to that side, I think, Jada, would you agree with me? It's going to be pointing up. So it's a loser minus. What does winner minus loser always equal? Well, we have forces from more than one mass, so it's going to be M all A. Now, first of all, why am I doing this? Why am I doing this, first of all? Yes. Why am I all scared? Sorry, but I had to do the scary thing because there's someone who responds well. Why am I scared? Why am I no longer relaxed? Everything. Okay, wait a minute. I'm not going to panic. When everything cancels, what number is left behind? Okay, so I get this. 0 equals m all a. What can I conclude then? Well, I have mass times acceleration is 0. Anytime you're multiplying and you get 0 as an answer, something has to be 0. Are the masses 0? No. What is 0 then? I think I've done this with you before. What do 3 dots mean? Therefore, A is 0. So what's the correct answer? A, B, or C? Yeah. That there is a lovely proof. No numbers, no English, all algebra. That's a good proof. I'm not expecting you to get to that this year. In Physics 12, on every test, there is a using principles of physics right to explain question, and we get pretty good at them. For those of you that are signed up for Physics 12, I'll start to say, prove it. You can always make up numbers, but eventually you'll get good at the algebra. This is actually really important. If you've been on an elevator in a high rise, the motor is actually only lifting the contents of the elevator car. Once you get off, the elevator car can just stay there at rest. They're not having to use energy to keep that elevator car at that height. It's a good energy saver. All right. I like example 2. There's going to be an Atwood machine like example 2 on your test. I'll be that blatant. Here's what I mean. In the diagram below, M1 is 1.2 kilograms, M2 is 3.8 kilograms, and I'm not looking at my phone. Annie, what does part A say? Really, free body diagram and winner minus loser. And then what does part B want me to find? And part C? Tension. Okay? I'm going to ask you to find the acceleration and the tension. I might just ask you to find the tension. Spoiler alert, you got to find the acceleration first anyways. But before we do that, this is a job for a free body diagram. What are the forces acting on M2, Annie? You get the obvious one. Which way? And for some reason, they called it M2, so I'll call this one M2G. Usually I put the M1 on that side, but it doesn't matter. What else? Good. Any normal force? Nope. What are the forces acting on M1? Get the obvious one. M1G. What else? Tension. This isn't a true free body diagram because I'm just labeling the picture. I'm not really worried about scale, but I got the gist of it. Who's winning? Which mass is heavier? Read the question. Is M2 heavier? Then this is going to accelerate this way. Now this bugs people because Mr. Dueck, M2 is smaller. Yeah, look, maybe this is lead and this is paper. I don't know. But M2 is heavier. It told me that. So that's going to be the direction of the acceleration. More important, that's going to be winner. Anything that ends up pointing down once it gets to the left-hand side is going to be winner plus. Anything that ends up pointing up once it gets to the left-hand side is going to be loser minus. So part A said, right, force equations. I can do that. Annie, who's winning? Good. And now walk along the rope. This tension right here, winner or loser? This tension right here, you might be tempted to say it's a loser because it's pointing up. But again, if you follow it, once it comes around to this side, winner plus. What about this M1G? You might be tempted to say winner because it's pointing down. But again, if you follow it, it ends up pointing up once it gets to the left-hand side, yes? So loser minus. What does winner minus loser always equal? M. Oh, is there more than one mass? Yeah, M all A. Tension cancels. So if you want to, you can stretch it out, which means we can't use this equation to answer part C. But we can use this to answer part B. Cooper, what does part B want me to find? Cooper's theorem. I'm going to be really lazy and just go M all means M1 plus M2. So for part B, I'm going to start plugging in numbers. A equals, I've scrolled down, Annie, what was M2? G, I've memorized that, 9.8. Minus, what was M1? G, 9.8. All over 1.2 plus 3.8. There is a bit of a built-in error check. If I cut this rope right there, the fastest the acceleration can possibly be is 9.8, because that would be free fall. You're going to get an answer less than 9.8 because M1 is slowing it down. M1G is slowing it down. All of you want to get out your calculators and try typing these in? All of you want to get out your calculators and try typing these in? I got to put brackets around the top. Typo, Mr. Dueck. 3.8 times 9.8 minus 1.2 times 9.8. That looks good. First thing, did you get 5.096? Yeah. Got a positive answer. That means we picked the right winner. If you got a negative answer, you picked the wrong winner. Try again. I'm going to write 5.1, but I'll store this on my calculator. Okay. Brendan, what does C want me to find? Okay. Nice thing is, it doesn't matter which mass you use, you'll get the same answer for tension. So pick a mass. You know what? Just this once, we'll do both masses. And then again, I won't do both again. Let's do, first of all, for M2, the one on the left. Which way is M2 accelerating, up or down? Is it? Is it? Which one of those answers is correct? Down. So which force is winning? So again, to find an individual force, we're going to write an equation for an individual mass. Don't you do this, but I'm pretending that that's not there at all. Who's winning? More specific. Which M? More specific. Thank you. Who's losing? What's that going to equal? M2A. Okay? So I'm going to go M2G minus tension equals M2A. How would I get the tension by itself? Ooh, what's right in front of the T that I don't like? Swappy dance. Plus that there, minus that there. I'll get M2G minus M2A. That equals tension. I'll get M2, 3.8, G, 9.8, minus 3.8. I'm going to use the full value, 5.096. Answer button. Nate, what'd you get for tension? 17.8 even? 17.9 even? 3.8 times 9.8 minus 3.8 times, haha, answer button. You get 17.8752, yes? 17.9, but just, okay. I could also have used mass 1. Would have worked. Carson, which way is mass 1 accelerating? Who's winning for mass 1 then? Who's losing for mass 1 then? You could go tension minus M1G equals M1A. How would you get the T by itself? It's going to be M1A plus M1G. Really quickly, let's go straight to our calculators. What was M1? 1.2 times, what was A? 5.096 plus 1.2 times 9.8. And Brendan, times 0.8, Mr. Dueck, times 9.8. I also get 17.875. It doesn't matter which one you pick, especially if you're using your answer button to carry all the sig figs through, you'll get the identical answer. Sometimes one will be slightly easier. I might have picked the right-hand mass only because tension is winning and it's a tiny bit easier to get the T by itself. But That's marginal. That's an Atwood machine. I'll give you both masses and I'll say find the acceleration, find the tension. Write an equation for everything to find the acceleration of everything. Write an equation for tension for one mass to find an individual mass for an individual force. Try number 3 on your own. I'm going to do it up here. I'm not going to freeze my screen, but I'm not going to talk to you. Try this on your own. Look up if you get stuck. If you have a handle on this, the test is worth about 40 marks. This will be worth about 5 to 7 of those 40. In other words, this is worth a big chunk. If you get the hang of an Atwood machine, I can't call it free marks. Jordan, you need to know what you're doing, but hopefully it's systematic marks. So I can get this. Free body diagram. Wow, come on, Ben. Cody, am I right? You got the same as me? Let me shrink this so I can get this on one page. Am I right, or did you get something different from me? I went really fast. I might have made a mistake. So I'll look for some confirmation. I have an answer. Yes. Looks like I used M1 and I was lazy. I noticed that M1 was accelerating up, so tension was a winner, which gave me tension minus M1G equals M1A. Or if you used M2, M2G would be a winner. It would be M2G minus tension equals M2A. Okay, so then you would use M2. So then you would swappy dance. You would have M2G minus M2A equals tension. And so you would go M2 5.7 times 9.8 minus 5.7 times answer button. Should have got 42.5021731, assuming you got an acceleration of 2 point. So now go looking for typos. Or am I wrong? Yeah. Yeah. So you couldn't have done the same equation. First of all, let me hit pause. Show you how many marks this is worth. See, I would give you 1 mark for that, 1 mark for dividing by m, that's 2. 1 mark for finding the acceleration, that's 3. 1 mark for finding a tension equation, that's 4. 1 mark for getting the t by itself, that's 5. And then 1 mark for the answer. These are worth 6 or 7 marks because there's a lot of steps to this. But they're systematic steps, I hope. Okay? Your homework is going to be some of these to practice, but first, look at example 5. Why is example 5 different? Yeah. I'm giving you a missing mass. I'm reversing the Atwood machine. I'm telling you either the acceleration or the tension, and that's enough for you to figure out how big the other mass has to be. There is going to be one of those on your test, but that's going to be tomorrow's lesson. In other words, I'm going to write pause here. You don't need to do that, but that's where I keep my digital record. What's your homework for now? If you go to the end, okay, you can try number 1. You can try number 2. 3 is good. These are all missing mass questions, which I haven't covered yet. That's a missing mass question. I think right now it's just going to be try 1, 2, and 3, but also you have homework to work on from your other lessons as well. Pause.